Hi everyone. Today I am going to discuss one of the important topic from your grade 12 first chapter, solid state. The topic is close packing in crystals. Student, close packing. What is the meaning of close packing? During the formation of a crystal, the constituent particle, what are constituent particle? Atoms or molecule. So during the close packing, during the formation of a crystal, these constituent particles get packed together, means they will come closer together. So what are the way we can arrange this constituent particle in a crystal? That we are studying in this topic. So the topic is close packing in solids. The close packing in solid, we can mainly classify it into three categories. They are one-dimensional close packing in two-dimensional, and close packing in three-dimensional. So let's study one by one. First of all, close packing in one dimension. In one-dimensional close packing, only one way of arrangement is possible. Let's see what is the one way of arrangement. In which the constituent particles, I told you the constituent particle we are considered as spheres. These constituent particles which are arranged in a single row, You can observe that. The constituent particle, these are the spheres which are arranged in a single row, in which they will ask you one question. What is the coordination number in one-dimensional close packing? What is the coordination number? So what is meant by coordination number? Student, coordination number you can define in two ways. The first one is the number of touching spheres, or we can say the number of nearest neighbors. Let me tell you. If you consider any of the inner sphere, let's consider this sphere. In this sphere, it is very clear that it is directly connected with the two atoms or two spheres, right? If you consider this sphere, it is directly touched with the two sphere. If you consider this, it is directly connected with the two sphere. So the coordination number in one-dimensional close packing is 2. What is meant by coordination number? The number of touching spheres, or we can say the number of nearest neighbors. So that is coordination number. So let's see here, what is the coordination number? It is very clear that the spheres are arranged in a single row. This is the central atom. If you are considering, it is directly touched with two atoms or two spheres. Therefore, the coordination number is 2. Now let's go for two-dimensional arrangement. How can we generate two-dimensional close packing? I already told you what is one dimension. The particles are arranged in a single row, right? If you take so many such rows, if you arrange the second row above the first row and third row above the second row, then you can generate a two-dimensional geometry or two-dimensional close packing. So let's study what are the different way of arrangement in two-dimensional close packing. Two-dimensional close packing you can classify into two categories. One is said to be square close packing, it is also SCP, and the second one is hexagonal close packing, that is said to be HCP. So two-dimensional close packing we can classify into two, SCP and the HCP, square close packing and the hexagonal close packing. Let's study about the square close packing. Square, right? Square. In square close packing, you can see this is our one-dimensional close packing. Let's take one more row and we can place over the first layer. In the first row, if you are arranging the second row, there are two different ways. Here you can see that where we are placing the second row. Try to understand where we are placing the second row. The second row we are arranging. All of you observe that where the second row is placing. Here you can see the second row is arranged vertically and horizontally exactly above the first layer. You can see this is the first layer, second layer, third layer, fourth layer. Where the second layer arranged? The second row is arranged exactly above the first layer, right? Exactly above the first layer, which is horizontally and vertically exactly above the first layer. Now let's study what is the coordination number in square close packing. What is coordination number? It is the number of nearest neighbors or number of touching spheres. If you consider any inner sphere, this is the inner sphere, suppose you consider, it is directly connected with 1, 2, 3, 4, right? There are 4 constituent atoms are there nearby the center. If you consider any other, suppose you consider this one, it's connected with 1, 2, 3, 4. So the coordination number in two-dimensional square close packing is equal to 4. Then why it is called it as square close packing? You can see, if you consider this central atom, or the sphere, it is I told you it is directly connected with the 4, right? One here, one here, one here, one here. If you are connecting these 4 spheres together, your results a square close packing. So this is said to be square close packing in 2 dimension. The coordination number is 4. How we are arranging the second row? The second row we are arranging exactly above the first layer, and the third row we are arranging in this exactly above the second layer. The fourth row we are arranging exactly above the third row. This is called it as square close packing in 2 dimension. In this square close packing, if you name the first row as A type, the second row is also exactly above the first row. That is also similar like first row. So it is also A type. Then again A type. So we can say that this type of arrangement or this type of close packing is said to be A type arrangement. So in 2 dimension, the first one is square close packing. It is a type with the A type because all the rows are in a single or in a horizontally and vertically exactly above the first row. Now let's discuss the second classification in 2-dimensional close packing, which is the hexagonal close packing. Hexagonal close packing or HCP. In hexagonal close packing, what is the major difference between square close packing and hexagonal close packing? In square close packing, this is the first row and you arrange the second row exactly above the first row like this. This is square close packing, right? But in hexagonal close packing, you are going to arrange the second row in the depression of the first row. What is meant by depression? You can see this is the first row. These are the 2 touching spheres. Can you able to see there is a gap? There is a curve between this side. This one depression, another depression. So the second row you are going to place in the depression of the first row. This is called it as hexagonal close packing. So student, if you consider the first row as A type, the second row is not exactly above. So we cannot call it as it's A type. It is in the depression of the first row. So we can call it as it is in another layer B type. So this is A type and B type. Now where you are going to place the third row? Third row you are going to place in the depression of the second row. Depression of the second row. So it will be again A. The third row will be again like a first row. Let me show you here. All of you see the diagram. Here you have the first row. You can see these are the depression. These are the depression area where we are placing the second row in the depression of the first row. And where we can place the third row. We can place the third row in this depression of the second row, right? If you name the first row as A type, we can say the second row is B type because it is not aligned horizontally and vertically. See all of you where the third row is represented? The third row is placed in the depression of the second row. It is very clear that the third row and the first row are same, right? You can see the third row and first row are similar, right? These particles are vertically and horizontally exactly above that. So A, this type is said to be AB type. So we studied in the square close packing, it was A type arrangement. But in hexagonal close packing, it is said to be AB type. Then why it is called hexagonal? Why it is called hexagonal? Let's see what is the coordination number in this geometry. You can see if you consider any inner atom or inner sphere, it is directly connected with how many atoms? How many spheres? You can see 1, 2, 3, 4, 5, 6. If you connect all together, you will get a hexagon, right? Hexagon. So this is called it as hexagonal close packing. Let's go to the 3-dimensional close packing. In 3-dimensional close packing, varieties of packings are possible. Let's see one by one. Here you can see, can you identify which type of close packing is this? This is our two-dimensional square close packing, right? So two-dimensional square close packing, it is just like a layer. You are going to arrange one more layer above this, second layer, third layer, fourth layer, then you are generating a three-dimensional close packing. If you consider the first layer, in this layer, it is just like, did you see the egg tray, right? In egg tray, the eggs are arranged in a horizontally and vertically exactly in a same row, like that. Just like a egg tray. If you are arranging one more the same type of layer above this one, you can arrange in different way. Let's study what are the different way. This is the first one. You have the first layer. Let me arrange the second layer exactly above the first layer. You can see that horizontally and vertically above the first layer. And this is the first layer and this is the second layer. Then where we can arrange the third layer, that is also exactly above the second layer like this. So fourth layer like that. So this is called it as three-dimensional square close packing. Three-dimensional square close, because square close pack the layers we arrange one above another. And here you can see that in this geometry, if you consider the middle layer, any of the middle layer, one of the atom, that is directly connected with this is the central atom, directly connected with 1, 2, 3, 4. These 4 atoms or spheres which are from the same plane, and this one above the plane, other one below the plane. So that we can say that the coordination number in three-dimensional close packing is, what is that? 6. So we completed three-dimensional square close packing. Let's go for three-dimensional hexagonal close packing. See, this is the first row, and you can observe these are the gaps between them, right? These are the gaps which is generated by the close packing of this layer. This layer, it is just like a geometry. What is that? It's just like a trigonal planar geometry, right? This geometry or that gap is said to be trigonal void. So what is mean by void? Student, void mean during the formation of a crystal, the constituent particle, when they coming closer, more gaps, more free spaces are generating in a solid. They are said to be voids. In this one, this is the first row. In the second row, we are arranging, see all of you, in the depression of the second layer, we are arranging in the depression of the first layer. So we can see that this layer and the second layer are entirely different, because this first layer, if you named as A, the second layer you can name as B type. So it's a type belongs to AB type arrangement. In this one, so many voids, so many gaps, so many free spaces are generating in this crystal. So mainly we are classifying voids into two categories. They are said to be tetrahedral void and octahedral void. Let's study detail about what is tetrahedral void and octahedral void. Let's see how these tetrahedral voids are generating in a crystal. You can see here is a 3 touching spheres. 3 touching spheres are there. When these 3 spheres join together, you can see there is a void or there is a free space generating in the crystal, right? This is called it as trigonal void. Why it is so? Can you see what is the shape of this void? What is the shape of this void? It's like just like a trigonal, right? Trigonal. This is called it as trigonal void. But here we are discussing about tetrahedral void and octahedral void. Let's see how these tetrahedral voids are generating. All of you see here, it's a trigonal, right? 3 spheres in a plane, and we are arranging one more sphere exactly above the trigonal void, and it is generating a tetrahedral geometry. Why the name tetrahedral? Because the shape of the void, shape of this free space in this structure is tetrahedral in shape. That's why it is called it as tetrahedral void. Now let's discuss about how the octahedral voids are generating, right? You can see there are 3 touching spheres which having a trigonal void. Another one, it also having one trigonal void. Now let me place like this. Okay, student, like this. Let me place it over the first layer. Now, if you place like this, if you observe inside, what is the shape of the void? you can see that it is having a octahedral geometry. It is having a octahedral geometry. Student, we are not checking that what is the shape of the sphere. We are checking what is the shape of the inside. What is the shape of the inside void? The void, the free space having a octahedral geometry. That's why it is called it as octahedral void. So we studied about what are the various possibilities of arrangement, the constituent particles in a crystal. One-dimensional close packing, two-dimensional close packing, and three-dimensional close packing. In one-dimensional close packing, we already studied only one way of arrangement is what is that? That is in a single row, right? In two dimension, we classified into two, square close packing and hexagonal close packing. In square close packing, the first row exactly above, second row, third row, like that. It's a type A type. In hexagonal close packing, in two-dimensional hexagonal close packing, this is the first row A type, but the second row, the spheres are coming in the depression of the first row. That's why it is called AB type arrangement. While we coming to the three-dimensional arrangement or three-dimensional close packing, we studied again two classification. They are three-dimensional square close packing. We see that two-dimensional layers we are stacking one above another, right? AAA type arrangement. Whereas in three-dimensional hexagonal close packing that we completed, two types of void. We studied about two types of void, tetrahedral void and octahedral void, right? So these are the three main classification in the close packing of crystals. So hope you get the idea. Thank you.